All right. So, last time we were working on measuring segments. Now we're going to be getting into angles. But before we can do that, we're going to look at the kickoff here. So, if we have 3 points, A, B, and C, and they're all collinear, so all on the same line, we know that B is in between A and C. So, B is in between them in the middle. So, if we take A plus B and B plus C, that equals AC. What is that postulate? Well, it's post 1-6, the segment addition postulate. Is how we can name it too. So, going to be looking at angles today. So an angle is formed by 2 rays with the same endpoint. The rays are the sides, and the point is the vertex, and is named by either the vertex. So, say if we had, say, angle 1, sort of thing, or the 3 points of the rays, or by a number. Yes, I should give it like this, or it'd be like angle C, or angle, say, A, B, C. So we could say angle 1, angle C, or angle A, B, C. Different ways you could do it. Well, how do we measure angles? Well, degrees with a protractor. And that leads us to the protractor postulate. So, if we let ray OA and ray OB be opposite rays in a plane, ray OA and ray OB and all the rays with the endpoint O that can be drawn on one side of AB can be paired with the real numbers from 0 to 180. So that ray OA is paired with 0 and OB is paired with 180. If OC is paired with X and OD is paired with Y, then measure of angle COD is the absolute value of X minus Y. So, long story short, what that's saying is basically we can have our one side be 0, the other side be 180, and in between there we could draw any ray and be able to measure it, and it would have a degree measure. So, 4 main types of angles. We have acute angles, which are 0 to 90, a right angle, which is exactly 90, an obtuse angle, which is 90 to 180, and then a straight angle, which is exactly 180. Now, that little square in the angle means that it's a 90-degree angle. So when you see it like this, that means a 90-degree angle. It's a right angle. So it has to have that in order to be a right angle. So if we look at this, here would be our protractor. We always line it up with 0 on the one end, and then we measure around to where we are. Now, careful with these protractors. When you do them, there are 2 angle measures going on. So the one side you'll see they start at 180 and it'll get smaller as you go around. The other one will start at 0 and it'll count up and get bigger as you go around. You want to use the one starting at 0 and building up. So here straight up would be 90, which, hey, that's B. So here 90, then we'd go 100, 110, 120 on this one here. Now, angles with the same measure are going to be congruent angles. So if the measure of angle 1 is equal to the measure of angle 2, then we say they are congruent. So their measures are equal, the angles themselves are congruent. Postulate 1.8, which is the angle addition postulate. This is going to be similar to what we did the last lesson with the segment addition. All it's saying is that, hey, if we have a big angle here, and we have a point in between that we can draw a ray to, we can add the smaller 2 angles together to equal the total angle. So think the 2 parts add up to be a whole. Now, if both of those add up together to be 180, then we know it's a straight angle. So same thing the other way. So if we know this is a straight angle, then they both have to add up to be 180. So what is the measure of angle TSW if RST is 50 and RSW is 125? Now, typically when we do this, there will be a drawing going on. Now, if this one was TSW, then this ray here should be R. Now, the other way we could draw this is RSW this way. So in this case, T would have to be in the middle here. Now, a couple different ways we could draw this, and it makes a difference which way you do it, because we know RST is going to be 50. Well, if we know RSW, the whole thing is 125, versus RSW here being 125, we get two different things. So I did this on purpose. Now, normally you'll either get a drawing and you'll see exactly what's going on, or I'll have in there like, okay, T is in between R and W. You know, it'll specify exactly which way it's going to be, so you don't have this confusion of, well, I did it this way and got this, and I did it this way and got this. There should be one way to do it, okay? Now, if it was this way, well, here we have a part, here we have a part, so we would add those two together. So 50 and 125 would make 175 degrees. If it's the other way, well, we have a part and we have another part that's missing. So we'd have 50 plus the x equals 125. Well, we'd subtract the 50 over an x would end up being 75. So big difference there. So very important to know which way it is. Again, there should be a drawing showing how it is, or there'll be some sort of description so that you don't have to try and guess. Now, we have certain pairs of angles that have special names to them. So first off, we have vertical angles here, which are opposite angles, and the angles or sides are going to be opposite rays. So opposite rays, so make a straight line, opposite rays, make a straight line. So 3 and 4 would be vertical angles, 1 and 2 would be vertical angles. And we'll talk about those more as we go forward about what their properties are and all that, but that's for another time. Adjacent angles are just angles that are next to each other. So 1 and 2 are adjacent because they touch. 3 and 4 are adjacent, they touch. There really is no specific measure with those, but just they share a vertex, they touch, they're next to each other. As we have supplementary angles. Now, supplementary are two angles that are adjacent, so they're next to each other. Is key there, and there's only two of them is the other key part here. But they're going to make a 90-degree angle. So like A and B, one could be 50, one could be 40. They go together, they make their 90. Now, if they're separate like this, they're technically not complementary because they have to be touching, they have to be sharing that side. Supplementary then are going to add to be 180. So if one's 105 and one's 75, together they make 180. As long as they're sharing that side, they are supplementary angles. So, knowing that and using this figure, we're going to show some examples of each. So a set of complementary angles. So complementary means add ups to 90. Well, we only have one here with the box, and that involves angles 2 and angles 3. So angle 2 and angle 3 would be complementary. Supplementary, they have to add to 180. Now you might be going, well, 1, 2, 3 together, they form a straight line, but that's 3 angles. We only need 2 angles to do that. So an example of that could be angles 5 and angles 4. Because it's only 2 of them to form a straight line. Supplementary adds to 180, 180 is a straight line. Now, an example of a vertical angle, well, again, it's just a pair, so there's only 2, angle 5 and angle 3. So they're opposite sides, their sides form straight lines. Opposite angles, I should say. Sides form straight lines. Now, if 1 and 2 are one angle together, then it could be a vertical angle of 4, but because these are 2 different angles, those 2 and 4 don't make vertical angles then. Again, it's just a pair. It's opposite angles, and that's vertical angles. Now, there are certain things that we can conclude when we just look at a figure. So one, we can look and tell that, oh, yep, they're touching their adjacent angles. We can also tell whether or not they're supplementary. We can tell if they form a straight line. That's something we can tell. We can also tell vertical angles. Again, we can see, do their sides form straight lines? Are they opposites? That's something we can do. Things you can't do, though, unless you have more information, are that whether angles or segments are congruent. We can't look at them and know for sure they're the same. They may appear to be, but unless we know for sure, we can't say. Or I should say, without more information, we can't say. We also can't tell if an angle is a right angle. It may look like it, but it may be 89 or 91 degrees. That looks really close to a 90-degree angle, but unless it has that box, we don't know. And then lastly, whether lines are parallel or if they're perpendicular. You know, we can look and it's like, well, they look parallel or they look perpendicular, but unless you know for sure, you have that additional information, you don't. So, what are some things that we can conclude here? Well, we know that angle 1 is congruent to angle 2 because they have the markings. Okay? Remember, like we have this mark, these tick marks here mean congruent. We could say that angles 1 and angle 5 are supplementary. We can say that angle 1 and angle 4 are vertical angles. We could say that angle 4 plus angle 5 equals 180 because they would be supplementary, just like 1 and 5 are. And then we could just go around and say for any of these, say for example that angle 4 and angle 3 are adjacent. And we could do that with any two angles. So that's it for this lesson. Let me know if you have any questions, comments, concerns. You can always pan me, send me a message on Google Classroom, email me, any of that works. Remember, anytime when you're going through these, you can always pause if you need time to write stuff down, or you can rewind and rewatch something. Don't forget to do that. Otherwise, until next time, we'll talk to you later.